Hello, everybody. So I will switch to English. So today I'm happy to be with you and present this about industrial applications. And I will talk about apples and about Solstice ZE. This presentation is prepared by Jean de Bernardi and myself, Wissam Rached. Let's do it. Perfect. So what will be inside this presentation? I will talk about 1230 Solstice ZE, which is a relatively new product because we'll see later why I say new. And we will see the properties of these products and compare it in a thermodynamic point of view and in a practical point of view, Solstice at work, what we call, and I will talk later about perspectives. So what about Solstice ZE? It's a very interesting, safe product that performs very well in different applications with a very low GWP and high performance. So let's go into details. Just to start, because I will talk about industrial refrigeration. So it's important to start by the history when this industry started. It was a long time ago, 145 years ago. As you can see in this picture, it's a boat to transport meat. Okay. It's about to transport meat from the Latin America to France. This boat is called Le Frigorifique. And inside this boat, there was a refrigeration installation using ammonia. So ammonia is installed in this kind of application and in industrial application since a long time. That's why I will take it as a reference today in order to talk about ZE, Solstice ZE, which is, you understand, is relatively a young refrigerant, not very old, but it's right now it's used in a lot of type of application, from heat pump to chillers to small application and up to process application in the industry for refrigeration, food process, and also it is used for producing electricity in organic Rankine cycle. So why this product is very interesting? Because it offers safety, it offers high performance, and a low total cost of ownership. So these points are very important today when we want to use a refrigerant. So all these properties give also a low carbon footprint for this product. So let's talk a little bit about thermodynamics. Here I will talk about ZE and compare it to the reference product ammonia, which is used since a long time. It's a standard simple thermodynamic cycle. And if we make calculation using these two products under the same conditions, we can see that there is a difference in the property between these two refrigerants. And if we make a focus on the COP, we can see that under this condition, ammonia have 5% higher COP than Solstice ZE. So it's a first step to understand the refrigerants, but let's go forward. If we don't stop at a simple cycle for this application, industrial refrigeration application, we can go to a little bit more advanced cycle where we can add a separator, liquid vapor separators, 2 expansion valve instead of 1 expansion valve, and we take the vapor from the separator and inject it to the compressor. So this can happen by using, and this cycle is used already in the application. It can be done by centrifugal compressors or screw compressors or also other type of compressors. So what will happen when we do this? I will apply this for different refrigerants and to see what will be the impact. So let's take 3 refrigerants. I cannot do all the refrigerant. I took the 2 main, ammonia and ZE, and I add R32 just for comparison. And we try here to optimize the operation condition of the system in order to get the maximum COP. And all the calculations are done for the 3 refrigerant under the same condition mentioned here in my slide. So let's go to the result where it's interesting. So when we apply this, we can see that for R32, we are, by optimizing the mid pressure, we are increasing the COP. So we can go to this point, which is approximately the maximum, and we can get plus 8% versus the starting point where there is a starting point, which is the basic cycle. If we take ammonia, we can get plus 1% increase of COP versus reference cycle. And if we take the solstice ZE, we can get plus 13% of increase in COP. So by using the same system, same condition, same performance, the result is not the same. Solstice ZE show a big advantage versus the 2 other refrigerants, and we get plus 13%. And by using this cycle, we have now, if we compare ZE versus ammonia, we have plus 5%, it's 4.9% higher performance versus ammonia system. So now let's go to a practical case. This case is not calculation, not theoretical thermodynamics. This case is about measurement. And why I show apples? Because it is in an apple storage, in a huge apple storage in south of France. This study is done by a company called Kersey Refrigeration. So I will talk about this. And in this huge apple storage, we have different chillers. So the company makes the choice to install 2 chillers, 1 ZE, 1 ammonia, in order to compare these 2 chillers at the same place, under the same condition, over the same period, to see what are the performance of each chiller. So as I said, before all, I like to thank Kersey Refrigeration, which own these results and allow us to share with you these results. So as you can see, it's a schematic representation of the installation. We have the different chillers. Here we see only 1 chiller in the graph. And all the comparison is done, as I said, between these chillers where are at the same place. So what did Kersey Refrigeration mandate an external company, which is Opti Energy, to make these campaign of measurement on these 2 chillers. So what we are talking about 2 chillers, one about ZE and one using ammonia. You can see the properties for each chiller here. Technology is the same technology, same compressor technology or equivalent, and same control technology. And what they did, they measured what are the consumption of each chiller, electrical consumption, and they measured the mass flow rate of glycol going out from its chillers and the temperatures. So this way we can have the energy efficiency ratio and compare what are the performance for each chillers. And here you can see the result of this campaign, where we can see clearly a big advantage of Solstice ZE chillers versus ammonia chillers. We are around plus 25% higher performance, which is very interesting value, and this will impact the investment of company because Apple storage are a huge installation and they consume a lot of electricity, and for them plus increasing electricity consumption by 25%, it's a huge impact on their business. And we estimate by 2 million saving through the lifetime of the installations. So we are talking about apples, and we make a Cursor refrigeration made an apple-to-apple comparison, and that gives these results. Now I will go through perspectives and technology. So I like to talk about what's happening around ZE. We know there is new technology already available in the market, which are all oil-free technology using ZE refrigerants, and this give an advantage for ZE over ammonia, where we cannot use the system without oil. Also, we have new compressor technology. We have turbo core technology, which are centrifugal compressors. They are all free and applicable to HFO and mainly Solstice ZE. There is other type of compressors, also screw compressors that can be used with ZE, with HFO, not applicable and are designed to be efficient with ZE. And also, if you remember my first slide in this presentation, small enhancement on the thermodynamic cycle can give big steps of enhancement on COP and energy efficiency ratio for this kind of installations. You can see also the reference, which are at the bottom of this slide. So a quick view around, like a comparison between ammonia and Solstice ZE. In fact, here there is nothing new. We can see that there is a lot of advantage from a refrigerant point of view to use ZE versus ammonia. We don't have the toxicity problem. We don't have this corrosive and irritant aspect to human being from ZE, which is the case with ammonia. We can use any type of metals with ZE. Full compatibility. We cannot use the coppers and zinc and other metals for ammonia. We have to use stainless steel. So there is a lot of constraint. The classification is not the same. And there is other aspect, like if there is mixture with humidity and water, ammonia can give toxic and heavy molecule toxic products. Also, I like to mention some problems with ammonia installations, that when we are using ammonia, we face a problem of humidity infiltration inside the system. And if we have this humidity infiltration, as probably you know or not, there is ammonia and water make an azeotropic mixture, which is toxic and corrosive. And this will complicate a lot the use of ammonia in installations, and it will decrease the performance of chillers using ammonia. And also there is a problem of miscibility of oil with ammonia, and we have to put oil separators, and which is not 100% efficient, and then oil can go through the system and accumulate in heat exchangers and so on. And to finish this presentation, I like to go through a kind of conclusion about what ZE can offer. ZE is a highly efficient solution for medium temp refrigerations, for process, industrial refrigeration. There is compatibility with a lot of materials. We can use coppers, for example, standard pipes. So it's easy to use, I can say. So ZE also doesn't produce TFA in a measurable amount, and that can be a problem for the environment or for animals. They don't produce PFAS. It is soluble with water, so if there is catastrophic leakage from ZE to water, it will evaporate. There is no reaction or nothing happens. ZE will go out from water. And if we compare with ammonia, ammonia is make an azeotrope with water, and it will produce a toxic mixtures. So let's conclude. It's the only product that have all these properties: safety, efficiency, and low total cost of ownership. Thank you.